All right, engineers, in this video, we're going to talk about the structure of the inner ear. All right, so what we're going to take a look at, just so that before, because what we're going to do is we're going to have an individual video on different sections of the inner ear. So what we're going to do is we're going to talk about the anatomy of the inner ear, and then again, we're going to separate each component into individual videos where we'll talk about them in great detail. So let's go ahead and get some anatomy down, all right? So first off, what is this big old structure right here called? This big old like snail-like looking structure. This big old beast right here is called the cochlea. Okay, so this big old structure right here that's nice and windy and swirly and stuff like that, that's called the cochlea. Now the cochlea is actually broken up into 3 different chambers that we'll look into great detail. Okay, so there's 3 different chambers of it. Okay, one of the chambers is called the scala vestibuli. Okay, the one in the middle, so this is going to be the upper chamber. Okay, so this is the upper chamber. In the middle is going to be what's called the scala media. And the scala media is really important because this is actually going to be a nice little endolymph-like structure. Okay, you know they also call the scala media the cochlear duct. So another name for the scala media is called the cochlear duct. This is the middle layer. Okay, so this is the middle layer. Then the lower layer, the bottommost layer of the cochlea, is what's called the scala tympani. Okay, the scala tympani, and this is the lower chamber. What's really important about this is that on the scala vestibuli, you're going to have a really important structure that we talked about within the middle ear. We said it was called the oval window. It's called the oval window. Remember the stapes? The stapes is tapping on the oval window. And when it's tapping on the oval window because of sound waves, right? The sound waves were actually creating vibrations that were compressing and decompressing the tympanic membrane that was moving malleus, incus, stapes. And stapes is tapping on this oval window. Well, really when it's tapping on the oval window, it's tapping on the scala vestibuli. Why is this important? Because the scala vestibuli is filled with a specific type of chemical, okay? A specific type of fluid which we call perilymph. Okay, it's called perilymph, okay, which is more of a harder-like fluid substance. The other one, there was a structure that was right inferior to the oval window. Remember that one? It was called the round window. So what was it called? It was called the round window. And if you remember, we said that the round window was important because if you remember, some of the sound waves are going to come through the different parts of the scala vestibuli, the scala media, and the scala tympani. What happens is some of those sound waves can get lost or scattered throughout the inner ear. We don't want that because it can interrupt the actual action potentials going to the brain. So what we want to do is we want the round window to prevent the actual scattering of those sound waves, to prevent the actual scattering of those sound waves into the different parts of the inner ear. Okay, so again, the round window is really important, and that's actually located within the scala tympani. And again, we'll look at this in a more deeper view when we get to this individual cochlea, and we'll talk about the spiral organ of Corti and a whole bunch of other stuff. Okay, but another important thing is the scala tympani is made up of what's called perilymph, which is more of like a harder fluid-like substance with a little bit of calcium and stuff in it, okay? Then the scala media, which is really, really important. The scala media, or the cochlear duct, which is the middle layer, is rich with a fluid called endolymph. And we're going to talk about endolymph a lot. We're going to talk about what kind of structures are making the endolymph. But what I want you to remember about the endolymph is that it is a potassium-rich fluid. It is a potassium-rich fluid located within the scala media, or the cochlear duct. So what you're able to notice here is that the scala media, which is filled with endolymph, is surrounded. Above it, it has a scala vestibuli, which is filled with perilymph. Below it has the scala tympani, which is filled with perilymph. Perilymph is what's called the outer bony labyrinth. Okay? So if something is made of perilymph, it's a part of what's called the outer bony labyrinth. So again, this one's made of perilymph also, so this would be made of. This is actually called the outer bony labyrinth. And then the structure that's actually made up of endolymph, the structure that consists of endolymph is actually going to be consisted to be called the inner membranous labyrinth. So it's called the inner membranous labyrinth. So the outer bony labyrinth, which is the scala vestibuli and the scala tympani, consist inside of it with an inner membranous labyrinth, which is made up of endolymph. Okay? All right, sweet deal. So that covers that part of the cochlea. We'll talk about a little bit more detail, but if you see right here, you see this little ending point here, you can see that the cochlear duct is this nice little blue structure here. So we can definitely clearly see here, this part there, which is called the cochlear duct. Okay, and then we're going to have, again, two different components. We're going to have what's called the oval window, and then we're going to have what's called the round window. And remember, we can have two chambers. Now, this isn't a perfectly formed here, but we're going to say that this part up here, let's say above the cochlear duct, this is going to be what's called the scala, what? Vestibuli. Below this is going to be the scala tympani. And in between is going to be the cochlear duct. Okay? And again, if you remember, we could say here would be the oval window, which would be where the stapes is tapping on, and below could actually be the round window. And the round window is where the actual preventing of the sound waves from being scattered. Sweet deal. And if you want to know one more thing, this point here at the end, if you follow the cochlear duct, it kind of makes this nice little spiral here. And it comes to this end point here. You see this end point here, right there? I'm going to write it here. This point here, where the actual scala vestibuli, so again, what would this one be? Scala vestibuli, scala tympani. You see that part where the scala vestibuli and the scala tympani actually come together and their perilymph combines? That's an important structure there. And that structure is actually called the helicotrema. Okay? So it's where the scala vestibuli and tympani perilymph mixes. All right, sweet deal. That's the helicotrema. Now, another thing that we'll talk about in great detail is you see this like doo-doo brown kind of like structure here? The doo-doo brown like kind of structure is actually called the cochlear branch of the vestibulocochlear nerve. Okay? So if you see this part right here, imagine there's actually nerve fibers coming through here. And they'll actually come through a ganglion, which is called the spiral ganglion. We'll talk about this in detail. But these axons are actually going to be a very, very important component of the vestibulocochlear nerve. So if you see these fibers that are coming out here, it's actually going to be an important component of the vestibulocochlear nerve. Okay? But this branch here, which is coming from the cochlea, is what branch? It's the cochlear branch of the vestibulocochlear nerve. So what branch is it? It's the cochlear branch of cranial nerve 8, okay? And cranial nerve 8 is going to be called the vestibulocochlear nerve. Okay. Sweet deal. So that covers that part. That covers the cochlea. Now, we're going to talk about the next one, which is going to be the vestibule. So what is this next part here? The vestibule is really important because the vestibule is a pretty decently sized structure here. Let's actually write it right here. This part here is the vestibule. Okay? It's a very kind of like, vestibule is kind of like the body. Okay? So this big whole part here, I'm going to kind of like encircle it here like this. Okay? If you kind of see, I'm kind of encircling around it here. All of this part here is actually going to be the vestibule. Okay? All that part that I moved around with the purple, that's all the vestibule. What's important about the vestibule? The vestibule is actually going to consist of two important structures. It's going to consist of what's called the utricle. Okay, internally. So the vestibule is going to consist of a structure called the utricle, and it's going to consist of another structure called the saccule. Okay, and again, we'll look at these in more detail. I just want to get you guys introduced to them. But what's important to remember is the vestibule is the outer bony part. So it's called the outer bony labyrinth. So the vestibule, which is this whole big structure here, it is an outer bony labyrinth. So what does that mean? That means it's filled with perilymph. Okay? It's filled with perilymph. So therefore, since it's filled with perilymph, it is the outer bony labyrinth. And again, inside of the vestibule, which is the outer bony labyrinth, it consists of the utricle. And the utricle is filled with endolymph. Okay, so this is filled with endolymph, which is potassium rich. Okay, this is potassium rich. And this is going to be the what? Inner membranous labyrinth. Okay, sweet deal. Same thing with the saccule. The saccule is a little bit smaller. See, the utricle is actually going to be, if you want to see where it's placed here, I'll show you where it's placed. So let's say that this one right here, that I'm going to point on with red, I'm going to bring him down here. That one right there is the utricle. Okay, so this upper one. So if you come here for the vestibule, let's say that this is the inferior portion, this is the superior portion. The superior portion here is going to be the utricle. The inferior portion here is going to be the saccule. So what is this structure here called? This one here. This is the saccule. Okay, so we have the saccule, which is the inferior part, and then over here we're going to have the utricle. And again, the saccule, what's important about the saccule? He's going to consist of endolymph, which is a potassium-rich fluid, and he's going to be a part of the inner membranous labyrinth. Okay, now, why am I mentioning all this stuff? And the reason why is because the saccule and the utricle, just like the cochlear duct, this endolymph is important because these structures, we'll talk about in way more detail when we get there, but they consist of things called hair cells. Okay, they consist of things called hair cells. Okay, and these hair cells are really important because the utricle and the saccule are a part of a larger structure. Okay, so really when we say vestibule, vestibule is the outer bony labyrinth. And if we really, really wanted to be super, super picky, the vestibule actually consists of this structure here. Now let's actually come back to this. It actually consists of a structure called the utricle and the saccule. But inside of the utricle and the saccule, they have a special structure called the maculae. So they have a special structure here called the maculae. And we'll talk about this in great detail because the maculae is important for static equilibrium, which is like whenever you are linearly accelerating. So if I'm actually going and I'm in a car and I hit the gas, boom, my head moves back. Or when I hit the brake, my head moves forward. So when I linearly accelerate and I decelerate, or when I tilt my head to the side. So if I tilt my head to the right side, I can activate these guys. If I tilt my head to the left side, I can activate these guys. Or let's say that I'm falling. I'm in an elevator and some terrible thing happens and the freaking cord breaks and I'm flying down. I'm flying down. That can also activate that. So a vertical deceleration could also activate these structures. Okay, so sweet deal. So again, the vestibule is the outer bony labyrinth filled with perilymph, consisting of the utricle and the saccule, which are filled with endolymph. These are the inner membranous labyrinth. They can contain a special structure, which are consisting of these hair cells. But these hair cells, as well with other structures here, you'll see them later. They're called an otolithic membrane with otoconia, okay, little calcium carbonate crystals. They make up what's called the macula, which is a special detector for what type of equilibrium. We said that this is for static equilibrium. Okay, like I said, we'll go into this in more detail when we get there. And since we covered this part over here, the scala media or the cochlear duct, it has a special detector. So it has special hair cells covered with what's called a tectorial membrane. And these hair cells with the tectorial membrane make up another really important structure called the spiral organ of Corti. Okay? And this is interesting for sound. Okay, so whenever I'm talking to you guys right now, the sound waves that you guys are hearing is carried out by the spiral organ of Corti. Okay? So auditory information is going to be picked up by the spiral organ of Corti. All right, sweet deal. We did that. Next thing, you see these suckers here, these canals? These canals, we have 3 of them. Okay, we have 3 canals. This one right here is called the anterior semicircular canal. I always put a U there for some reason. Circular canal. This one in the back. So it's coming here and it's moving posteriorly. This one right here is called the posterior semicircular canal. And then you have one, imagine it coming out at me like it's punching me in the face. Okay? So imagine this bad boy is coming at me to punch me in the face. This is coming out laterally. Okay? Because remember, this is an internal structure. So when this is poking out, remember we said that this was actually a little depression within the middle ear cavity or the tympanic cavity, the medial wall. So this guy is trying to come outwards. He's trying to go outwards towards the ear. So this is actually going to be lateral semicircular canal. Okay, so now that we got that, the semicircular canals, what's important about these guys? The semicircular canals are going to be the outer bony labyrinth. So outside of this, again, imagine kind of like I'm kind of highlighting it right here. You see all this stuff that I'm trying to like move in with like little lines? That part there is the outer bony labyrinth, which is made up of perilymph, okay? Now, why am I telling you that? So the outer bony labyrinth here, which is made up of perilymph. So it's consisting of perilymph. So this is the outer bony labyrinth. Inside of it, there's this nice little blue structure there. What is that blue structure there called? The blue structure inside of this is called the semicircular ducts. Semicircular ducts. Another important thing is the semicircular ducts. So this is a whole semicircular duct here. This is a semicircular duct coming back, and this is a semicircular duct going this way. All right? But these semicircular ducts dump into a nice dilated region, which I'm going to kind of highlight here in pink. Let's say that this one right here kind of dilates right here. This kind of dilates. This kind of dilates. And that kind of dilates. Those little dilations at the end part of the semicircular canals here, as it's getting ready to go into the vestibule area. These little dilated regions are called the ampulla of the semicircular canals. So what is this part right here called? What did we say this was? This little dilated regions here. And these dilated regions here are called the ampulla of semicircular canals, right? So it's the ampulla. So that dilated region there is consisting of a very, very special structure. So at the ampulla of the semicircular canals, that dilated region right there, there's semicircular duct right there. So the semicircular ducts are moving all the way around, but they have little dilated regions right there. That dilated region, which is in the ampulla, is a very, very special detector. That special detector, which is in the ampulla, it consists of these hair cells that are covered with like a collagenous, gelatinaceous membrane called the cupula, okay? And that basically makes up a very, very special detector called the crista ampullaris. And the crista ampullaris is important for what's called dynamic equilibrium. Okay, what do I mean? If I decide to turn my head to the right, turn my head to the left, or I decide to do circles, this guy is really important because he's helping to maintain my balance, my posture, my equilibrium whenever I'm doing head rotations or angular acceleration. So he is good for, crista ampullaris is important for angular acceleration, whereas the maculae, which is consisting of the utricle and the saccule, that's important for static equilibrium or linear acceleration, okay, whether it be horizontal or vertical. And then the last one, which was the cochlea, which is consisting of the cochlear duct. These hair cells are important because the spiral organ of Corti is detecting sound waves, vibrations in the air, okay, and turning that into electrical potentials for us to perceive. Okay, so in this video we covered that. Now one other part here. Let's do this one and this color here. You see this part here? This is actually another branch of the vestibulocochlear nerve, cranial nerve 8. But this branch is coming from the vestibule, and it's coming from the what? It's coming from the actual semicircular canals. But I guess maybe they don't have much love for the semicircular canals, but they are coming off the vestibule. But they call this branch that's moving with the vestibulocochlear nerve, they call it the vestibular branch of the vestibulocochlear nerve. So what is this branch here called? Holy crap, get rid of that one. This is called the vestibular branch. Vestibular branch of cranial nerve 8, or the vestibulocochlear nerve. And just like I said, this had spiral ganglion, okay? These also have a ganglion along the way. It's actually part of what's called Scarpa's ganglion. Okay, so these are the pseudo-unipolar cell bodies, which have their peripheral processes coming out here to the vestibule and the semicircular canals, and their central processes going into the central nervous system. Same thing here. Spiral ganglion have their peripheral process coming out to the cochlear duct, and they have their central process going into the central nervous system. All right, and they'll take these informations into the cochlear nuclei, and we'll have that. I'll talk about that in the actual auditory pathway. Okay, whereas the vestibular branch will take it to other structures called the vestibular nuclei, and again, we'll have another video on that. All right, so ninja nerds, we covered basically the anatomy of the inner ear. What we're going to do is we're actually going to have individual videos where we're going to focus on the vestibule and its structures inside. We're going to have another video on the semicircular canals and the structures that are inside, those special detectors. And then we're going to have another video on the cochlea and the structures that are inside. And we're going to talk about how static equilibrium is being affected, how dynamic equilibrium is going to be affected, and how sound waves or sound is actually going to be affected. So if you guys need any extra help with a little bit more of the actual ear anatomy, we're going to have another video that you guys can click out on the corner of the video. It's going to be going over the external ear, the middle ear, and the inner ear. And we're actually taking a model, an anatomy model, and you guys can see that in a little bit more depth if you guys need a little bit more help with that. All right, but ninja nerds, other than that, I hope this made sense. I really do hope that you guys enjoyed. If you guys did, please hit the like button, comment down in the comment section, and please subscribe. As always, ninja nerds, until next time.